right, here we go. Let's try this one. I would say a nice thing that they've done for us is that it's already in factored form, but there are certain parts of the problem where you don't want it in factored form. So then you have to multiply it back together anyway. So again, it's a hit and a miss. All right, here we go. Step one. Let's factor, domain, reduce. Well, they've already factored it, so we're good there. Let's find our domain. Our domain, let's see, I don't want x to be -3, and I don't want x to be 4. But guys, if you notice, there are technically 2 factors of x minus 4. So in reality, I don't want x to be 4, and I don't want x to be 4. So that's that multiplicity of 2, that even multiplicity that I said it will give us a clue about what happens around that vertical asymptote and the behavior that it has. All right, so just take note of it, that it's definitely a multiplicity of 2. All right, so, but really it just can't be at one time when you're actually talking about it. All right, so that makes our domain any number from -infinity to -3, union from -3 to 4, union 4 to infinity. All right, now we would go back and reduce, right? We always want to make this easier to work with. Unfortunately, I have no like factors on top or bottom, so nothing reduces. All right, so now we can go to our VA. Our VA is, well, who still is really, really bad for the bottom? Who looks bad? Well, since nothing canceled, -3 and 4 are both still really bad. So they'll be our vertical asymptotes. So I'll have a vertical asymptote at x equals -3 because my graph cannot exist there. It's an x value that I'm not allowed to plug into this function. And I'll have one at x equals 4. But remember, he had multiplicity 1. This one had multiplicity 2. So again, that is a clue about what's going to happen around that vertical asymptote. Let's put them on the graph. All right, so this one had odd multiplicity at -3, and it had even multiplicity at 4. Because again, we're all about shortcuts. The quickest way to put this graph together without having to plug numbers in. So that'll be a clue that we can use later. All right, now let's go after our horizontal or our oblique asymptote. Well, if you think about it, if you were to multiply this all out, this would become an x squared. An x squared times an x would be an x to the third, so that's a degree 3. Over, same thing, if I squared this, I would lead with an x squared. An x squared times an x would be an x to the third, so that's a degree 3. So I have a degree 3 polynomial over a degree 3 polynomial. According to asymptote rule number 2, that means there will be an HA, no OA. And it means your horizontal asymptote will be the ratio of the leading coefficients. So that'll be the line y equals, well, our leading coefficients, 3 over 1. And again, even if you multiplied this out, this one would lead with a 3x to the third. This one would lead with a 1x to the third. So it's 3 over 1. Guys, time out. My sister is calling me and she has my kids. Just give me 1 second. I just don't want to. My son is sick. Hello? Oh, crap. Okay. Are they being held in like an office? Okay. Okay. I can't do it until 10 minutes. Can I wait 10 minutes? I have to get through this class. All right. I'm back. What? Okay. Okay. I didn't do my kids' COVID forms, guys. I'm that mom right now. Darn it, sorry. All right. And he's not sick with COVID. He just has a cold. Okay, so It's okay, Alyssa, we're okay. All right, so here we go. Y equals 3. Okay, so just to kind of assess the situation, we know we're going to have a curve to the left. Maybe it's in the top, maybe it's in the bottom box, maybe it's both if it crosses over. We're going to have a curve in the middle, maybe in the top box, maybe in the bottom box, maybe both if it crosses over. I'm going to have a curve to the right, either in the top box or the bottom box, maybe both if it crosses. All right, here we go. By far, the worst step of all is checking to see if it crosses, okay? And this one's going to get pretty nasty. So if you don't mind, I'm going to erase this for now because I need a lot of board space. And it's never a good sign when your teacher says that. I know that, all right? But here we go. Don't want to erase that. All right, so we have to take the function, which is this one. So this is actually step 4, seeing if it crosses. Take the function. And this is where I feel like it being in factored form doesn't help us. Because if I'm going to solve for x, I'm going to have to probably multiply this out. All right, we have to set it equal to the horizontal asymptote, which was the number 3, and I'm going to put it over 1. And we're going to find out if this function ever equals 3. All right, so let's cross multiply. So the easy one is here. Right, this times 1 would be the same thing. Equals 3 times all of this. Okay, now I have to solve it for x to see if there is an x value or values, plural, that it crosses over the horizontal asymptote at. Well, guys, right away, I can divide the 3's out. I don't need the 3's. I can divide both sides by 3 and they're gone. All right, I'm going to FOIL this out. And that would get me x squared minus 2x plus 1. If I did x minus 1 times x minus 1. Equals x plus 3 times, if I FOIL this out, that'll be x squared minus 8x plus 16. Everybody okay? We're all right? Yes? All right, just some algebra here, some heavy-duty algebra. All right, now I'm going to multiply these together by distributing my x and then distributing my positive 2. So I'm going to get x to the third minus 2x squared plus x. That's me distributing the x to everything in the second parenthesis. Now I'm going to distribute the 2. 2x squared minus 4x and then plus 2. All right, that's going to, let me just clean this side up. X to the third. My negative 2 and my positive 2x squared cancel. I'm going to get negative 3x and then plus 2. That's what that reduces down to. All right, now I'm going to come over here. I'm going to distribute this. X to everything and then positive 3 to everything. X to the third minus 8x squared plus 16x. Then I'm going to distribute my 3 plus 3x squared minus 24x and then plus 48. So my x to the third will come down. Negative 8 and positive 3 get me negative 5x squared. So now they're okay. 16x's and negative 24 are negative 8x's. And then positive 48 comes down. Everybody okay? We're just foiling our little hearts out here. Okay. So now, oh my God, now my dad's calling me. I get it. All right, here we go. So it's probably my son telling me he doesn't want to go to school. Oh, what a crazy day. All right, so now, if I go to solve, right, my x to the thirds are going to cancel. Depending on where I try to move them, they cancel. All right, I'm going to move my x squareds to this side, because I like the number in front to be positive. So that's going to be 5x squareds. I'm going to add my 8x's. So then negative 3 plus 8x is positive 5x's. And then 48 to this side, 2 minus 48 is negative 46. Woo! Now we got a quadratic. Oh. Guys, time out again. This is, we're having major issues with my children. I apologize. I'll tell you right now, I would try to solve this quadratic by factoring. It doesn't factor. Now you got to use the quadratic formula. I told you, this one gets nasty. So everybody right now, solve this using the quadratic formula. Just give me a second. I apologize. Yes, Lovey. What's up, bud? How do you feel? Is your nose runny? I don't know, do you think you can make it at school? It's just a cold. Oh, okay. I have to finish this problem now. I'm in the middle of class. I can't do this right now. Yes, buddy. Okay. Yes, love. How about you try to do a little bit of work, but you don't have to go to the meet then? All right? All right, I love you, bud. I'll call you back. All right. Oh, sorry. All right, plug it into the quadratic formula. So you end up with x equals -5 plus or minus the square root of 945 divided by 10. So guys, use your calculator and get an estimation. What numbers are these? Do -5 plus the square root of 945 divided by 10, and do -5 minus the square root of 945 divided by 10. And you end up with x equals 2.57 and x equals -3.57-ish when you round them. So that means it's going to cross over the horizontal asymptote not once, but twice at these two x values. So go to where x is 2.57, which is 2.5-ish, and put that dot right on the horizontal asymptote. It's going to cross when x is about 2.5. It's also going to cross when x is -3.5-ish. So go to where x is -3.5, and put a dot right on the HA, because it's going to cross over that horizontal line 2 different times on 2 separate curves. This curve crosses it, and the curve in the middle crosses it. All right, so guys, I just wanted you to see that, how nasty that can get. All that multiplying out only to end up with a quadratic that you have to use the quadratic formula on. Yeah, all right. All right, now it's a little bit smoother sailing from here on out. But I need to erase this, so hopefully you're okay with what I wrote. Okay, so now we're going to step 5. We're going to get some legit points. The first one I ask you to get are any holes. Well, guys, you would only get a hole if one of our factors canceled out, but nothing canceled, so there's no holes. Which I like when there's a hole because it's just another point that I know a curve has to pass through. It's another clue as to where my curve is going to be. All right, now we're going for intercepts. Our x-intercepts. Well, set the function equal to 0 and see who x equals. Right, cross multiply. So again, in reality, it's just the numerator who ends up being set equal to 0. All right, I can divide the 3 out. He's gone. I'm going to get x equals -2 is one of my x-intercepts. And I'm going to get x equals 1. But guys, if you notice, there's really 2 factors of x minus 1. So really, you get him as an x-intercept 2 times. So that means this x-intercept has an even multiplicity. And do you remember what the graph does at a 0 with even multiplicity? it bounces. It just touches that x-intercept. Okay? All right, let's put them on the graph. So it's going to cross the x-axis when x is -2 and when x is 1, but this one is special. It's going to bounce when it hits him. It's not actually going to cross over. It's going to be tangent to the x-axis there. All right, let's get the y-intercept. We got to plug 0 in and see what number comes out. So if I do that, that'll be 3 times 0 plus 2 is 2, times 0 minus 1 squared is 1, over 0 plus 3 is 3, and 0 minus 4 is -4, square it is 16. So you end up with 6 over 48, which is 1/8. So you have a y-intercept at 1/8, which is like just barely above the x-axis. Okay. From here on out, now you would be doing test points. I would suggest maybe plugging in, this is -3, plug in -4, -5, -6. See where the curve is if you can't see it yet. Plug in, you can plug in -2.5. You can plug in -1.5 or -1. Just start creating more points. I think we have enough to go off of where we shouldn't need to plug anything in. Guys, let's focus on here. Look at all these dots we got going on in the middle, right? Think about it. These 3 dots have to connect. Are they connecting where he crosses and then comes back up? Well, he can't cross because if he comes back up, he can't get to that y-intercept. So he must be going from this dot to this dot to this dot. Remember, this one is a bounce. He's going to bounce right off of him. And again, it couldn't be coming from up here because where would the curve be coming from with these asymptotes? The curve has to be coming from down here when he crosses. And then what's it going to do? It's going to approach that asymptote. So I know the curve is doing this. And then it's going to bounce. Now I have another dot to connect. It's going to cross over and then head towards that asymptote. Again, it can't come down. It can't cross over again. It's got to go up. Now, if this has even multiplicity, that means any VA with even multiplicity, the curves on either side, they have to go off to the same infinity. When it is odd multiplicity, they have to go off to odd infinities or different infinities. So now I know if this is an even multiplicity, the curve on the other side has to go off to the exact same infinity. There's no crossover, so I know it stays in this top box. I also know it couldn't be in the bottom box because I have no x-intercepts over here. So how could it be in the bottom box? There would have to be an x-intercept for it. So now I know this curve is doing that. If I come over here, this VA had odd multiplicity, which means the curves on either side have to go to opposite infinities. So if this curve is going to negative infinity, the other side has to go to the opposite infinity, which means it's going to come from up here, go through that cross, and then hug the asymptote on the other side. Now again, it might dip down a little bit. I know it doesn't cross over the x-axis because there's no x-intercepts for it. So even if it dips down a little bit, eventually it has to come back up and follow that asymptote as x goes to negative infinity. And there are your curves. But again, if you have trouble feeling that or seeing that, then you're just going to have to use test points. You're going to have to plug x's in to create official points. All right, guys, that's a workout. That's a really, really long problem because of all that multiplying and that quadratic formula. But the graph itself comes together pretty quickly once you see the what the information has given you. Is that okay? Yeah. All right, everybody at home, are you okay? Any questions? Are we all right? Okay, and like I said, I did not create a new homework for you guys today. I figure work on the day 1 and the day 2. You have enough graphs right there to keep you busy. Tomorrow, I just have to show you. They're going to give you one already graphed, and then you have to come up with what the equation was. We'll do that tomorrow, and then that'll be the end of this section. And then your work for the rest of the week and the weekend will just be looking on the study plan. I did post your study plan. There are 13 mastery points for the 3 sections, 4 sections. 4-3, 4-4, 4-5, and 4-6. Out of the 13, I think you only have to get 6 or 7 mastery points. I tried to keep it at half because I know that that study plan is a lot of work for you guys. but if anybody wants to review anything, it's a great way to review, okay? If you have any questions, obviously reach out to me. Let me double check the attendance and then I'll let you